Good day to everyone watching this presentation. My name is John Rakshis, and today I'll be discussing or talking about the paper IoT and Computer Vision Associated PMS for Biosignal Monitoring and Emotional Recognition. So I'd like to start off by showing you all this number. This is the amount of deaths caused by medical errors in hospital for the year 2018, and this is found from a study conducted by Johns Hopkins. And these are the topics that we will be discussing in the paper today. So this project aims to create a system that can monitor a patient's physical and emotional conditions 24/7. So the system will monitor a patient's heartbeat, temperature, and emotional state, and this system basically uses an IoT platform to generate accurate results and helps it be easier to integrate with other systems. So how this works is that the system gives a score for vital and emotional conditions, and this score is updated periodically. And when the score is found to be above a certain threshold value, the hospital staff are immediately notified and requested to attend to the patient. So we read a lot of papers to achieve what to create the system that we've created, and this will talk about some of the systems that were already existing that were similar to ours that we improved. So the key topics or the key papers that we found out were recent trends of IoT applications in PMS, computer vision and its learning algorithms benefits in PMS, introduction of facial emotional recognition in PMS. Starting off with the first one, there are estimated to be about 50 billion IoT connections in 2020, and this number is only expected to increase to 100 billion in 2025. So the ability to transmit biomedical data that were received from sensors and which could be visualized and directly sent to a physician's remote desktop was the base of this system. And in the last 2 years, smart IoT mini devices were specifically engineered to monitor patients who were admitted to an ICU. So if you can turn your attention to the circles down there, both of them are basically systems or pre-existing systems. So the BioSense Health 1.0 basically monitors a patient's vital health and provides statistics about that patient. And the IoT Me device is a device that can monitor the health condition of an elderly person in a home environment. However, we found a research gap where all the proposed devices required much more human involvement due to the various discrete components present there. And none of the devices accounted for mobility or freedom of the patient, and they also did not account for the emotional state of a patient. Okay, so let's start with the next topic, which is the computer vision. So computer vision is a field of artificial intelligence that trains computers to look at the visual world and helps identify and classify objects accurately. So the learning methods used in computer visions is normally CNN or convolutional neural network, AE or autoencoders, GANs or generative adversarial networks, or it could also be the restricted Boltzmann machine, or it could be a combination of multiple systems to form a hybrid system. So the research gap found here was that the CNN was most commonly applied in computer vision due to its excellent image classification and face recognition compared to other methods. So for this specific project or paper, we applied the CNN method. So let's take a look at the introduction to facial emotion recognition in patient monitoring system. So there are 3 steps to a successful facial emotional recognition. Number 1 would be image pre-processing, where this plays as a transition where there's a low or highlight images, which needs to be evaluated comprehensively in order to reduce the error that will come in the following stages. The second one would be feature extraction, where we extract certain individual components from a face, such as an eyebrow, the eyes, the mouth, or various other regions. And the third would be to classify these identified components. And this uses a neural network, which is kind of trying to replicate the concept of neurons in a human brain. So introduction to facial emotional recognition PMS. So there's a problem that we identified here, which is as good as machine learning may seem, it is restricted to produce a good recognition result for, for very large or big data sets. With, let's say if you give it 5 similar faces, the system can learn those 5 similar faces very easily and provide accurate results. But if you give it 5,000 distinct faces, it would take much more time and much more computational power, and the results at the end of the day are not super accurate. So to battle this issue, deep learning algorithms were reported or were found out to be some of the most effective methods to solve this restriction, especially in terms of CNN or convolutional neural networks. Hence, it was chosen to be the detection algorithm used in this project. So let's take a look at the system components here. So as you can see, all the way to the left, we have the emotional detection units components, which basically consisted of a Raspberry Pi with a camera module attached to detect the person or the patient's face. Then in the middle, we have the vital detection unit components. So this included a heart rate sensor and a temperature sensor, which was connected to a Node MCU ESP8266. So this Node MCU is basically an IoT device. This is what enables us to connect this information to the IoT. In a future slide, we will see how this works. But for right now, both of these components work in harmony to send all of the data to an IoT cloud for further processing. So let's take a look at the overview of the system. So as you can see on the image above, there's a Raspberry Pi and a Pi camera, which is basically pointing towards the patient. And if you can see on the patient's hand, he's wearing the vital signs unit, which is further detailed below. There's a temperature sensor attached to his hand and also a heart rate sensor, which is connected to the Node MCU ESP. And if you can see, this data is basically transmitted to the IoT cloud, where the data can be visualized and it's sent back to the remote desktop. So this is the system connection. A BPM or a beats per minute or a heart rate sensor is connected to the Node MCU along with the temperature sensor, and this is connected to the battery for power. And the Raspberry Pi has a Raspberry Pi camera attached to it, and this already comes with a power source, so we don't need batteries. So let's take a look at the flow of the sensor data. On the left again, we have the vital signs unit with all of its components. On the right, we have the emotional unit with all of its components. So as you can see, according to the waveforms, they both are transmitting their data into the IoT cloud, which is then visualized by the IoT system itself using multiple other systems. And this information that has been visualized is sent to the remote desktop of the doctor. So let's take a look at the proposed model here. So there's 3 modules as discussed below. We have the emotional module, the vital module, and the IoT module. So the emotional module works in such a way that the emotional module is used to capture a stream of the patient's face, or it takes multiple images through a Raspberry Pi camera. Then these individual images are sent to the image server through MQTT protocol, and all of this happens within 5 seconds. And then after the images are being sent, it's received by the emotional recognition artificial intelligence or AI model, which enables it to identify the patient's emotional state using its own algorithms. And then this image is received from the Raspberry Pi and it's processed. Then the probability of the emotions are calculated based on the AI modules discussed above, and this gives out a calculated probability of the emotions, which is sent to the IoT cloud in the form of a JSON format file, as it is the easiest to access and visualize. Okay, so if you can see, let's take a look at some of the emotions that can be identified by the AI module. So firstly, we have anger, disgust, happiness, sorrow, neutral, surprise, and fear. So the vital module comprises of a Node MCU, a heart rate sensor, and a temperature sensor or a thermal sensor. And this vital module is completely wireless and it's equipped with a battery for power autonomy. And this IoT platform ThingsBoard is the platform that is used to receive the data from the other modules and visualize it. So let's take a look at some of the results. So as you can see, this image here is a sample of what the emotional recognition unit can see. So it firstly places a box around the person's face, which is bounded to be the detection area, where the individual components of the face are extracted, identified, and based on a confidence level, the emotion is detected and given. So the emotional module results. So the AI model that we used was trained based on an FER2013 dataset, which is basically a type of dataset that is used for supervised training. So there are 7 labels of sentiments or emotions in the FER 2013 dataset, which is neutral, disgust, fear, surprise, sadness, happiness, and anger. Then for the testing data, a sample of 4 images were recorded to depict 4 of the primary emotions, which is anger, happiness, sadness, and surprise. So the results of the vital module. So as you can see, this graph on the left basically gives out the patient's heart rate and temperature reading periodically. So basically, the patient's heart rate and temperature readings are measured in intervals of 5 seconds. So every 5 seconds, as you can see on the graph, a new reading is obtained. So this happens throughout a minute, and it forms this graph on the left. So if you can see, there's the total number of beats, the time, and also the temperature, where the red line or the red readings represent temperature, and the black readings represent the total beats or the BPM. And the inset image that you see above those dotted lines basically shows the real-time data being visualized in the IoT ThingsBoard platform. That's how it looks in the IoT platform. So the average value of 66.08 beats per minute were identified along with the temperature of 34.5 degrees Celsius, indicating that this was a normal resting heart rate. To thank you all for your precious time and attention, and I hope you all have a nice day.